All right, so I'm gonna get to MathLab my way for me. Oh, and y'all see that first assignment that says course agreement? You have to do that to actually start accessing the homework. Now that course agreement does not count with any math related material. It's just material that you understand that they got a drop date and all that fun stuff. Um, but all you can do is answer I agree on every question. So it's not like a test or anything, but we got it set up as a quiz so that you can get started out with a really good score in the class, okay? But it's only one answer you can put on that course agreement, and it's like 4 questions, I think. You just answer I agree, I agree, I agree, and be done with it, okay? So let me get us to my section 2.1. You'll notice this one has 7 questions. So I'm going to start us out on number 1 here. So y'all, this one says graph by plotting points. And they're giving me y equals 3/2 x plus 2. All right, so I'm going to go back to my pad now that I got the problem. We'll work this out and then we'll go back to the pad and put in our answers. All right, y'all, so this is a straight line. You got a x here, and technically that x would have an exponent of a 1 by it. But anytime you got this type of a graph, it's going to be a straight line. This is sort of in this form. So it's this form of a line, okay? Your slope, variable, that's your y-intercept. But in this class, the best way to graph is going to be by plotting points. Okay? So to plot points on this, you would set up a little x and y graph, a little table here. You would pick 2 x values because for this type of graph, for number 1, when we go to MathLab, we're going to use this tool, and this is called a 2-point line tool. So since it's a 2-point line tool we got to use with 2 points, that means when I graph it, I need at least 2 points to put into MathLab. Okay? Now, I'm sort of going to draw a hand graph of this as we're going. So y'all, 2 points I need. I need 2 x values, and then I'm going to solve it for the y value and put that down. Y'all, one of the easiest points to always use on a graph is a 0. I'll use 0 100% of the time, okay? So what I would do, put that 0 in for the x. I would have y equals 3/2 times 0 plus 2. I would work this out and then get my y value here. So I picked 0 because 0 times 3/2, that's a 0. Bring down my plus 2. And y'all, 0 plus 2 would give us 2. So when x is 0, my y value is 2. So let me make some points on my graph here. And that's a good thing about MathLab. You don't have to draw all the graphs to turn them in. We can plot them in MathLab, okay? I just sort of do this to get y'all back in sync with how to plot points. Remember, x's go left and right, zeros in the middle, You got 1, 2, 3, 4, 5 going to the right. You got -1, -2, -3, -4, -5 going to the left. To the left, they keep getting negative as you head out toward negative infinity. And then the right, you're going to keep getting positive towards positive infinity. Now the y variable. The y variable goes downward if it's negative, and the y variable goes upward if it's positive. And 0 for the y is right in this center here. This is what we call the origin of the graph where they intersect. And that's the 0 point for both lines here, okay? So since the 0 was on the x, 0 on the x-axis is right here at the origin. So once I'm at 0, the y value being 2 means that I would go up a positive 2 in the y direction. So I would go up to 1, 2. At 2, I would put my first point. Now y'all on this one, since this is a fraction and I don't want to try to graph a fraction on here, when they're in this form, my second x, I'm going to pick a 2. I pick numbers that match that denominator here. And I'll show you why I'm doing that. So if I got y equals 3 halves times 2 plus 2, well, y'all, if you wanted this to look like a fraction when you multiply, just put a 1 under it. But fractions multiply straight across. So 3 times 2 is 6 on top. 2 times 1 is 2 on the bottom. So that's going to give you 6 over 2, which would equal 3. So that's if you multiplied straight across and then divided that answer. Now, y'all, let me show you why I pick a 2. This 2's will cancel, turning that into a 1. 2 divided by 2 makes that a 1. And basically, this is 3 times 1, which is still 3. So you can either multiply, then do the division to get that answer, or you can sort of divide like I did, the 2 divided by 2, and then multiply to get that answer. And then that's what? Plus 2 comes down, and y'all, 3 plus 2 would give me 5. So when x is 2, y is 5. So I go right 2. So remember, always start in the center, go right 2 for the x's, and then the y value is 5, so I would go up 1, 2, 3, 4, 5. At that point, I would draw my line through them points, okay? So y'all watch what's cool about this class. Let me share a little thing that you're going to want to get, and that is a TI-84 calculator. So we go to y equals, any graphing you do is that top left button that says y equals. Now, if you want it to look like a 3 halves fraction, here's how you do fractions. You hit the green alpha button, you click y equals, and then ND, that means fraction. That's like numerator, denominator. So you just hit enter on that. It'll bring up the little box. I can put my 3 in top. I can arrow down and put my 2. Now I'm going to arrow right. Now when I get the X, I use the X that's right to the right of the green alpha button. It's got an X, a T, 0 with a line and an N. Well, since we're in y equals, we can hit that button and it'll put an X up there for us. And then we put plus 2. So 2 things you can do. You can hit the second blue button, and on the top right, hit that graph button. And if you hit the blue button before the graph button, it'll give you a table of all the values. So see, when we had x was 2, 0, you get a 2. Now if I go down to, I picked a 2. At 2, that y value was 5 like we had. If you go to 4, you would have got an 8. But y'all, it looks like on this one, if I'd have used Odd numbers for my x's, like 1, I'd have had to plot 7 halves. If I'd have used a 3, I'd have had to plot 13 halves. So that's what I try to avoid is graphing fractions and all that. That's why I did the 2 to cancel out that denominator. But y'all don't matter. You can graph it in here, pick 2 points that you think you can graph, and then let's click graph by itself, and it'll show you the graph like we drew a while ago on our paper, okay? All right, so that's using that calculator. So let's go back and put it into MATLAB now. So under the problem here, it says click to enlarge graph, that gray thing there. I'm going to click that. It's going to pull up a graph. So the first tool is just the object selection tool. We don't really use that. The second one on the top row is the line tool. See how it's got 2 points on it? Next to that is the absolute value. We'll use that a little bit later. You got a parabola tool with 2 points. Those are going to be the main 3 we're going to use in this section. So we had a line tool, so we're going to click the line tool. And then we just go over here and plot our points. So my first one was 0, 2. So I'm going to start at 0 for the x's and go up 2 for the y value. Click that. That's going to put my first point. Then it's telling me to plot my second point. I had 2, 5. So starting back at the middle, I'm going to go 1, 2 to the right and up 5. So you got to be careful on this one because it looks like each of the tick marks for this one went by 2s. So you just have to be careful. And if you see this, let me clear this a second. This yellow band on top, as I'm graphing it, watch how it shows me my point. So let me do 0, 2 again. See on the top right, I'm at 0, 0. And then I went 0, 1, 0, 2, click. And then we had 2, 5. So starting at the bottom, I went right 2. And then I'm going to go up 5. So that'll show the points as you're graphing it, okay? All right, then what? You save it, and then you check your answer. All right, y'all, let's see this next one. They got 6y plus 3x equals 9. Now, this is one of those where we got to solve it first. So the easiest way for this one is to solve it first and see what we get. So I'm going to solve it first. Because if you solve it, then you can use your calculator to get your points. Okay? So you want to solve it for the y. So the first move is to get the 6y by itself. So I'm going to move this 3x to the other side. Now, to move stuff from side to side, you're either going to add or subtract. So since this 3x is positive on this side, you would come in and subtract 3x from both sides. And that's one of the golden rules. What you do to one side of an equation, you do to the other, right? So what happens? This side, I get my 6y. Them canceled out on the left side. Now, the right side, you got a number and an x. These are not like terms. I cannot add a number to a variable, okay? So you can write that like this. 9 minus 3x. Or you could write 6y equals negative 3x plus 9. This is the way that looks like the y equals mx plus b form. But y'all, really, you can do it either way. Okay? It don't matter. As long as the x's are negative and the 9 is positive, okay? So to finish this out, I need to make this a 1y and it's a 6y. So since I got 6 being multiplied by the y, I need to make that a 1y by dividing by the 6. Now, multiplication and division are distributive, which means you got to do it to every single part of the equation. So you need to divide the 9 by 6, and then that minus 3 divided by 6. Okay? Every single term has to be divided. So here, 6 divided by 6 makes that a 1y. And y'all, you just got to remember, if I don't put a number in front of these variables, it is always understood to be a 1. All right, so 9 divided by 6 doesn't happen. So we don't want mixed numbers, but what I will do is reduce this down. 9 and 6 both have 3's in them. So if you divide 9 by 3, you'll get a 3 on top. And if you divide 6 by 3 on the bottom, you'll get a 2. So always reduce the fractions, okay? And remember, all I did, y'all, was both of them divided by 3, and that gave me a 3 halves on that, okay? Now here you got a 3/6. Both of them will divide by 3. And that'll give me what? A 1 half. So I got 3 halves minus 1 half x. All right, y'all. So this one is a little trickier because you got 2 fractions in it. But I'm still going to pick some numbers that I think will be easier. I think I'm going to use a 0 again. So that's going to give me y equals 3 halves minus 1 half times 0. All right, so I'll bring down to 3 halves minus 1 half times 0 is a 0. And y'all, that's going to end up giving me a 3 halves. Now, here's a trick I do. It's hard to figure out what to do graphing fractions, but if you'll turn that fraction into a decimal, this decimal form of 3 divided by 2 is a 1.5 that I can graph. Okay? So if you don't like fractions, turn it into a decimal. All right, y'all, my second number, I'll just put a 1 in for that x. So that'll give me y equals 3 halves minus 1 half times 1. So bring down your 3 halves minus 1 half times 1. Well, anything times 1 is itself. So 1 half times 1 would be 1 half. Now, subtracting fractions, they got a common denominator. That common denominator stays on the bottom. All the adding and subtracting gets done on top. So I got 3 minus 1, which will give me a 2. And y'all look at that. 2 divided by 2 gives me a final answer of 1. So when x is 1, y will be 1. So y'all, let me show you how you would graph these on the math lab, okay? All right, so we're going to click to enlarge our graph. That's still a line tool. So click the line tool. My first point was 0 for the x. My y value was 1.5. Now watch that little yellow band as I move. There's 0.5, there's 1, there's 1.5, click. Then I had 1, 1. So starting at the center, go right to 1. Now remember, it's moving by halves. So 1 half, 1, and then 1 half, 1. So there is 1, 1, click. And y'all, you just hit save. Now, calculator. Remember, you could have done it on the calculator. But y'all, here's the trick on your calculator. Let me clear everything out. On the calculator, I had y equals 3 halves minus 1/2 x. So I'm going to use my fraction, alpha, y equals, enter. That was 3 halves, so 3 on top, 2 on bottom, arrow right. Then it was minus 1/2. I'll do alpha, y equals, enter for more fractions. That'll be a 1 on top, 2 on bottom, arrow right, and then hit the X. So let me show you the table. Second graph for the table. Now you can go negative on these also, remember. But I used a 0. There's my 0, 3 halves. And then we used what, a 1. And there's our 1, 1. So that's our points. So let's look at the graph. Hit enter. Hit graph. And there's that graph going downhill to the right. And if you look at our math lab, our graph is going downhill to the right. So check that answer and then move on. All right, so now we'll get into graphs that are not straight lines. So I got y equals negative 2x squared. So I'm just going to pull up this. So on this one, when you got an x squared, y'all, this is going to be the U-shaped parabola. And if I click on that, it says 3-point quadratic tool. That's what we're going to use on this graph, okay? So let me go back to my paper. So this uses the 3-point quadratic tool. Anytime you have this x squared, we're using this tool, okay? Now, these graphs will either look like a U or they'll flip over and look like an upside down U on this one, okay? And y'all, here's the thing you got to realize on this one. Any number you square right here will become positive because like signs are always positive. But this one, since you got a negative 2 in the front, it's going to turn all these positive x squared values into a negative value when I multiply by that negative, okay? If this was a positive 2, then all these positive x values would stay positive. But y'all, we got that negative up front, so let's watch out for that. So 3 easy numbers to square. You could do a 0, 1, and a 2. You could do -1, 0, 1. Anything you want to get 3 points is what we need on this one, okay? Now, I picked small numbers because the graphs are going out to about 10 or so on those axes. So, get numbers you can square on this one, okay? So let me start out by putting a 0 in for that x squared. That's going to give me y equals -2 times 0 squared. So bring down that -2. So you're going to hit the exponent first. And 0 squared is 0. So 0 squared is 0. And then -2 times 0 is 0. So looks like when x is 0, y is 0 on that one. So let me go and put a 1 in. So bring down the -2. because we got to do the exponent first. 1 squared would be 1 times 1, which is 1. And then negative 2 times 1 gives me a negative 2. So when x is 1, y is negative 2. All right, y'all, then I'm going to put in a 2. Y equals negative 2 times 2 squared. Once again, I would bring down to negative 2 and do my exponent first. So 2 squared would be 2 times 2, which is 4. And then look here, negative 2 times 4 would give me a negative 8. Now, y'all, if you'd have did negative 1 here, let me show you what would have happened. You would have had y equals negative 2 times negative 1 squared. Well, you would have brought down that negative 2. Negative 1 squared would be negative 1 times negative 1, which would be a positive 1. And then negative 2 times 1 is negative 2. So this one you would have had a negative 2, 0, and then at 1 we got negative 2. These graphs are symmetric. These parabolas that we call them from the x squared graphs. So whatever you get for the negative x values, you're going to get for the positive x values. So like negative 2 and negative 2. So here, since 2 is negative 8, negative 2 would have been a negative 8. These are symmetric graphs, okay? All right, but either way, you can plot either one of these and get the correct answer. So let's go to MathLab and plot those points. All right, so we're going to click to enlarge graph. X squared, you're going to go to the second row over here and pick the 3-point quadratic tool. Now, it don't matter what order we plot our points. I had a 0, 0. I'll put in the center. Whoops, I think I got offline. Let me cancel that and start over. All right, 3-point quadratic tool, 0, 0, click. I had 1, negative 2, so I go right to 1, down to negative 2. And then watch this, I had 2, negative 8. So go to 2 and down to negative 8. So there's 2, negative 8, click that. When you put the third point, it draws your curvy parabola, okay? So look over here, I could have did that negative 1, negative 2, and got the same graph, okay? So you save that, and then you'll check your answer. So y'all, let me go back to my calculator real quick, and I'll show you how to graph that one. All right, so that was negative 2. So use the negative down here in the parentheses. So click that negative 2. And it was x squared. So I'm going to hit the x. On the left side, right above the, sorry about that. Right above the 7 and left, you see an x squared button. If you hit that, it'll put those exponents up there for you. So I now have a negative 2x squared. Let me show you the table, second graph for the table. So you see how these x values at negative 3, you get negative 18? Positive 3, you got negative 18. And then there's our 2, negative 8, negative 2, negative 8. These graphs are symmetric, like I said. All right, we want to look at the graph. And y'all, there's our little upside down parabola we just drew, okay? So if you look back at MathLab, we had that upside down parabola, okay? All right, let's see what they got next. Y equals x squared plus 2. All right, y'all. So this is the same type graph here. X squared plus 2. You still got this x squared term in here. So this is still going to be the 3-point quadratic tool that we're going to need, okay? So we still need 3 points. So y'all, I'm going to keep my number small on this one, do a -1, 0, and a 1. So let me start out by putting a -1 in for my x and squaring it. Now, the thing you got to realize, if you punch this in the calculator, you better put any negative numbers in parentheses when they got exponents. The calculator will give you a wrong answer if you did it like this. If you put it like this, the calculator will give you a -1 for the answer. That's wrong. In the calculator, you got to put -1s in parentheses, and then it knows that -1 times -1 equals a +1. It won't square the negative unless it's in parentheses, okay? All right, so this -1 squared equals 1, so that gives me 1 plus 2, which equals 3. If I put the 0 in, I get 0 squared plus 2. Well, that's going to be 0 plus 2, which is 2. So when x is 0, y is 2. And then we put in a 1. Now, positive numbers, you don't have to put in parentheses. It's going to square that 1. 1 times 1 is 1, plus my 2. And 1 plus 2 is 3. Y'all, if you're using numbers like this and you're using negative numbers and positive numbers that match other than their sign, y'all better be getting the same answer on these y values, okay? So -2 and +2, they would have the same y value, and so on, okay? So calculator, y equals, clear that out. We had an x squared, so x, square that, plus 2. All right, y'all, watch this. Go to second graph to get my table. So I started at -1, so there's -1, 3, 0, 2, and then 1, 3. All right, let's look at the graph and see what it's going to look like when we graph this. So it's going to look like a positive, what do you call it? A U-shaped parabola there, okay? So let's go plot that in MATLAB. So click to enlarge graph. Second row, you want the 3-point quadratic tool. Click that. And then I'll do my left to -1 up to 3. I had 0, 2, so at 0, go up 2. And then I had a 1, 3, so go right to 1, up 3. So I got my 3 points. You save that, and then check answer. All right, y'all, let me ask y'all just a question here. Let me go back to my pad. And I'm going to pull my chat up real quick. Um, do all y'all have access to the TI-84 calculator? If I'm getting a lot of yeses, let's see. So, Marlon, you don't have the physical calculator. Marlon, let me ask you this. And you, Claudella, if you don't have a calculator, do you have an iPhone? And how about you, Claudella? You got an iPhone? Okay, so let me show y'all this. On your iPhone, there's a little app called Calculate 84. calculate 84 in your app store. If you download that, watch this. I can punch it on that app. That app will pull up the TI-84 calculator. And it's just like mine. I can go to Y equals, and I can put in my, well, it's hard to see mine because of my Zoom. But it's going to, it's not showing everything, but it should be saying Y1. Let me see if I can zoom that in a little. Well, y'all, it's not zooming in, but it says right here Y1, Y2, Y3, Y4, and all that fun stuff. The buttons on that app are the same as the buttons I've got on my calculator, okay? So, y'all, if you do not have a physical TI-84, use this app, Calculate 84, on your iPhone, and it'll be the same exact thing. It's got the graphing capabilities. Every button is lined up just like my calculator. So y'all try those, and you should be able to get around that, okay? All right, y'all, so let me see what they're giving us next. Oh, look at that. This is number 5. Y equals, and it's got some bars around the x minus 4. So do y'all know what them bars represent?
Absolute value.
There you go. So it's a function, but it actually is the absolute value function. So let me show you on this, on right here real quick. On the top row, that V-shaped graph right there, if you click on it, it says absolute value tool, and it's got 2 dots on it. But let me tell you one thing about it. You see that little dot in the V right there? When I click on the absolute value tool, it says click to graph to plot the vertex. The vertex is that little V, that dot right there on the V. So let me show you what they mean by that. Well, let me pull my paper back up. So this is the vertex, and we'll learn about that a lot more later in life. On toward the end of our second week, I believe. But the vertex has to be the first point you plot. So let me tell you how to find the vertex on these graphs. So you want to choose an x value that makes the expression. So this is basically an expression, but we want to choose an x value that makes the expression equal 0 inside the absolute value bars. So I needed 2 points, remember? So y'all, what I need is an x value that'll make that equal 0 inside these bars. So what are you picking? Oh, y'all got the first day jitters. So what number could you subtract 4 from and make that equal 0? All right, Holmes, a good job. That is definitely a 4, y'all. So watch this. That's going to give me y equals absolute value of 4 minus 4. And y'all, let me tell you this. In order of operations, absolute value has the same priority as parentheses. So they're the first thing you got to evaluate. Well, 4 minus 4 gives me 0. And absolute value 0 is 0. So that means the vertex on y'all's number 5 will have a y value of 0. All right, now I can pick any other point. I don't care what number I use. You can put a 0 there. If you want to use a 0, put a 0 there. So that'll give me absolute value of 0 minus 4. So the first thing I'm going to do is work inside my parentheses or my bars. 0 minus 4 would give you a negative 4. So y'all wonder, what is the absolute value of a negative 4 equal? Good job, Martin. It is actually a 4. The absolute value of any number will be positive, okay? I don't care what sign it is inside there. If it's a positive 4, absolute value of 4 is 4. Absolute value of negative 4 is 4. Absolute value inside those bars will come out as a positive number, okay? The only way to make these things negative is if they had a negative in front of the bars. If it had a negative in front, then every answer would have been negative, okay? But anything inside those bars comes out as a positive answer. Now, y'all, those are a little tricky to find on the calculator. So let me go to clear everything out. So to get absolute value, there's 2 ways you can do it. The first way, you can hit the blue second button, and then down here hit the 0. Above the 0 it says catalog. So if you do the blue button and the 0, it brings up the catalog of everything in the calculator. Well, y'all, ABS is the very first thing. That stands for absolute value. When you click it, it puts the bars up there, and then you just put in your x minus 4. And then if you want to arrow out, do like that. And there you got x minus 4. Second way. So the second way to get absolute value would be to hit the math button. Right under the green button, there's a math button. Hit that math button. Arrow over to the number where you got number highlighted. When you highlight number, look at that. Number 1, ABS. Hit enter. And that's your absolute value. So then you put in your x minus 4. Now remember, this looks like a V. So watch this. When I hit second graph for the table, and we was at what, we picked 4. So if you go down here where 4 is, you get 0 like we got. But look at that. On the left side, you got 3, 1. On the right side, you got 5, 1. And then 2, 2, 6, 2. These graphs are symmetric, but they're symmetric from wherever your vertex point is, okay? So remember, when I graph this, I definitely want to graph the 1 first. If you're doing the calculator instead of hand, you want to pick the one that has the y value of 0 for your first point. Now let me show you what would happen. Let's look at the graph. So that graph comes down, left side touches at the x-axis at 4, and then it goes uphill. Okay? Now, going to Math Lab. We got our V-shaped tool clicked. So my first point was 4, 0. So let me go right. There's 4, 0. Click that. And then my second point was 0, 4. So go to 0 and up to 4. But see, it automatically mirrors the right side off of what we're doing with the left side, okay? Now, y'all, I want to cancel this. I want to show y'all why you got to do the vertex first. So say you come in and you plotted 0, 4 first. So watch this. Here's 0, and there's 4. And then I plotted my 4, 0. Well, y'all look at that. That don't look like my graph because they're thinking the vertex was that first point. So you're going to get the wrong graph if you do not plot your points right. You got to do the 4, 0, and then 0, 4. You must start with that vertex on that one, okay? All right, y'all, what's next? Oh, y equals x cubed plus 2. All righty, so back to the pad. X cubes. Well, my thing's in the way. So for the X cubes, I didn't show you the tool yet, but these X cubes, if you got a cube like this, we're going to choose the tool. It looks like a squiggly line. And guess what? It has 4 points. So we want to use the 4-point cubic tool. So on this one, I would definitely use small numbers because when you cube stuff, numbers can get big cubing them. So I use numbers like 0, 1, and 2, and -1, or -2. Those are my 5 best numbers. Put 3 in there. 3 times 3 times 3 is 27. That's a big graph. 5 times 5 times 5 would be 125. So be careful with your cubes, okay? So for this one, I would put a 0 in. Well, 0 cubed is 0 times 0 times 0, which is 0 plus 2, and 0 plus 2 is a 2. Then I'd put a 1 in there. So 1 times 1 times 1 is 1 plus 2, which gives me 3. All right, y equals 2 cubed plus 2. Well, y'all, 2 times 2 is 4, times 2 is 8. Hamza, what you got? 10, perfect. So that'd give me a 10. And then we'll do our -1 cubed plus 2. And y'all look here, -1 times -1 times -1 is -1 plus 2. And y'all, -1 plus 2, what y'all got there? 1, good job. So these are small numbers. Like I said, if you'd used a 4, a 5, a 6 even, whoo, you would have had big numbers. So we got our table. Let's look at the calculator here. Y equals, I'm going to clear that out. All right, y'all, so I got x cubed, so I'm going to hit my x. Now the cubing, you got to do different than you did with the squares. On the right side under the clear button, you see a little upside down V. Hit the upside down V, that puts your exponent in, and put your 3. Now, arrow right to come back down and put in a plus 2. Okay, so any exponent other than a 2, I'm going to use that little upside down V we call a caret. All right, y'all, let's look at the table on this one. So second graph, I'm going to my table. So y'all look at that. -3, you would have had to plot a -25. There's our -1, 1, 0, 2. We had 1, 3, 2, 10. But y'all, you get these numbers very big. Look at that. You put a 3, that's 29. 4 was 66. 5 was 127. So those numbers are really huge to try to graph, okay? All right, y'all, let's watch this one in MATLAB. Click to enlarge graph. Second row, 4-point cubic tool. Click that. And then you just start putting your points in. So I had 0, 2, click. I had 1, 3. So right 1, up 3. I had a 2, 10. So go right 2, up 10. I'm watching that little yellow band to make sure my points are right. That was 2, 10. And then we had -1, +1. But see, after that last point, you sort of got that little squiggly line going uphill to the right. So at that point, save that, and you can check your answer. Oh, y'all, I don't think we looked at that one on the calculator. So let's go back to the calculator. We never hit graph, but here you go. When you hit graph, there's your little squiggly line, okay? So let me put my calculator ain't on a 10 by 10. Let me hit zoom. To reset the graph to a 10 by 10, you would go down to zoom number 6 standard, and there you go. I got my 10 marks now. And also that, there was one more in here. Let me see what they had on that next one. I think it's another x squared graph. We done did the x squared graphs like twice. So I won't be doing that one. So let me stop our share. Um, any questions so far, y'all? Okay, so y'all are looking good then. All right. So y'all, let's knock out section 2 then. We won't do a support today because y'all haven't done any homework yet. So we won't know what you're going to need fixed on. So we'll just do our 2.2 and that'll be it for today. Um, Now what we'll do starting tomorrow, we'll do our lectures starting at 10. Once we get done with our lectures, I'll see if any of y'all need support help on any homework and stuff. So that's all I use that support lab for, is to help y'all on homework if you need it and stuff like that, okay? So I don't make it required unless you get behind in the homework. If you start getting behind in the homework, then I'm going to sort of make you go to the support lab so we can get y'all caught up, okay? And also, this next section is not bad. It teaches you about functions, okay? So let me get back to my pad. So y'all, this is 2.2 and it deals with functions. So first thing I got to do is, what is a function, right? So for us, a function is going to be a correspondence. So correspondence is where they sort of relate x values and y values together, okay? So it's a correspondence in which each x value has one and only one y value. Now you can remember these as x values are like your input, the y values are like your output. You put an x in, you want a y out. So to be a function though, you can put one x value in and you only get one y value out. Just like y'all's paychecks. If you work by the hour and you work a certain amount of hours, you want them to figure out your pay based on, say, you work 20 hours. You want them to put in that 20 hours and come out with one pay amount. You don't want to give them a choice on what they pay you. So a good function, one input, one output. X values cannot have more than one Y value. But y'all listen, you can have two X's or three X's even. They can all have the same Y value, okay? That'd be like if you worked on a salary, 20 hours, 40 hours, or whatever. No matter how many hours you work, you get one pay. So different x's can share a y value, but each x individually can only have one y value that it's going to, okay? So x's can only have one y value. But several x's can share a y value. Okay? So I'm going to draw an example here. See what we do, and then we'll look at MathLab and sort of play with their problems, okay? So we're going to determine if the correspondence is a function. Okay, so they'll give you a domain on one side and your range. Now remember, the domain is your x's, the range is your y values, okay? Oh, so let me see. What if I had one like this? 15, 6, and 13. Those are my x values. And in my range, I got a 17 and a 20. So the 15 is going to the 17 here. The 6 is going to the 20. The 13 is going to the 17. So the question of the day, is this correspondence a function? Y'all got any guesses on that one? So, good job, Hamza, because look here. And Jayla, good job. All these x values, 15 only points to one y value. 6 only points to one y value. 13 only points to one y value. So y'all, that one is definitely a function. So y'all hang on a second. Let me get that MathLab pulled up here, and we will play with some of their problems. Oh, y'all, so I'm going to share the screen. We'll go to the MathLab now. All right, y'all, so what do you think? This is pretty much like the one I just did, right? So, yes or no on this one? Cynthia, y'all got yeses on there. Good job. This is basically the one I just did. They're pointing at one each. So we'll go a yes on that. All right, y'all, your final check. You hit next question. Is this one a function? Yes, good job. It's still a function. All these x values, they're only pointing to one y value. And remember, we said several x's could share a y value, right? But here's what we got to say. You got to go down to C because each element in the domain corresponds only one element in the range. See, B is right as far as yes, but it says the range corresponds to one in the domain. Well, y'all, that range, if you look at 5, it's got 3 different domain values. So that's absolutely wrong. So it's got to be C. The domains correspond to one element in the range. All right, so y'all got that, and let's see what's next. Is this a function? Okay, y'all pretty quick on that. Good job. No, because 16 is pointing to two different y values. 9 pointing to two different y values. 4 pointing to two different y values. So that's definitely a no on that one, okay? Is this number 4 a function? Chicago points to the Bears, Bulls, and Cubs. Boston's pointing to the Celtics, Bruins, Red Sox. Genesis and Marlin and some of y'all, what? No, good job. Because each of them is pointing to three different range values. So that's violating our definition. It's a correspondence, but it's not a function, okay? Oh, y'all, that's a trick. All right, so new thing coming up. So let me go back to my pad. Now we're going to start getting into function notation. And y'all, you're going to find these first few days is sort of a refreshment, sort of going back over old things and stuff. So function notation, that's this f of x. So really, f of x is a y. It's basically the y value, but we use f of x notation because we're letting you know that it's a function and that x is the variable. Okay? This lets us know we have a function and that x is the variable. Okay. Now, it ain't always an F. Sometimes they'll use G of X. If you get into science classes, they might have a A for acceleration. F might mean force in a science class. Um, but these usually represent what the formula is for. But for us, it's per function. Now, X is the variable of the function, they're letting me know. So here's the thing. If a number is used in place of the x, then that number is substituted in the expression for the variable. So what I mean, if they give me a function and they say f of 2, then that means I'm going to put a 2 in for all the x values in that expression, and then I'm going to evaluate it. Okay? So let's do an example so y'all can sort of see what I'm talking about. So watch this. Given f of x equals x plus 9, they want me to find the following. They want us to find f of 0, f of negative 2, f of negative 4, f of a positive 2, and f of b plus 20. So basically, 1, 2, 3, 5 things they want us to find. Okay? So they want me to start with f is 0. Well, here's my expression, x plus 9. So f is 0 means they want me to put a 0 in for the x, so that this becomes a 0 plus 9. Now, all we do is work the right side. We don't do nothing with this f is 0. That's just telling me what we put in for the x's. All you do is work the right side. 0 plus 9 is 9. That's your first answer. So that takes care of f is 0. I got f of negative 2 next. F of negative 2. Well, y'all, they want me to put a negative 2 in for that x. So that's going to equal negative 2 plus 9. Right, all I do is work this side. Negative 2 plus 9 gives us a positive 7. That takes care of f of negative 2. And that's all we're doing is substituting whatever number they give me inside the parentheses for the x. F of negative 4. I'm going to put a negative 4 in for the x. I got negative 4 plus 9. All right, y'all. Negative 4 plus 9 is a positive 5. So that takes care of f negative 4. Next, I got an f of 2. So basically, this function notation is shorthand. So let me see. So yeah, exactly. That means my y value or my function value would be a 9. Because they're basically the same. Good job, Hamza. That's true, okay? All right, y'all, on this one, put a 2 in for the x. You get 2 plus 9. Well, 2 plus 9 is 11. So that takes care of f of 2. And I think it's really because we can say stuff like, hey, find me f of 2. I don't have to say, hey, what's the value of the expression when, what would I say? What's the y value when x is 2? That's a lot of stuff to say. All I got to do is say f of 2 instead of what's the y value when x is 2, okay? Oh, y'all look at this one. F of b plus 20. Well, guess what? In place of this x, they want me to put a b plus 20. So that's going to be b plus 20. That's the x, and then plus 9. Can you go further on that one, y'all? Good job, y'all. We can definitely go further. Because remember, good job. Y'all did it. Y'all did it. Y'all added them like terms together, and we got a b plus 29. Cannot go any further, so final answer. All right, so that takes care of our f of b plus 20. So they're going to play with you a little bit and throw variables at y'all to see what you're going to do with them variables, okay? All right, y'all, let's try our next one. So for this one, I'm given g of r equals 5r plus 9. So my function's a g, but they're telling me the variable is r. And if you look, that's what I got in here, r, right? So let's see what they want us to find. They want to find g of 2, g of a negative 5. Oh, and look at that, g of a 6.9. So they're throwing a decimal at us. We might have to multiply on a calculator or something, but no issues. All right, so only 3 on this one. So let's start with g of 2. All right, y'all, so we're going to put a 2 in for the R. So it's going to give me 5 times 2 plus my 9. All right, so I'm going to see if y'all got order of operations down. What is that answer? Ooh, good job. Y'all going quick, too. Because 5 times 2 is 10. 10 plus 9 was 19. Good job. All right, G of -5. We're doing the same thing. 5 times my R, which is -5, plus 9. Oh, that's quick. You and Jada rolling too. Because 5 times 5, -5 is a -25. -25 plus 9 is definitely -16. All right, y'all. So y'all got a tricky one coming up. G of a 6.9 equals 5 times 6.9 plus 9. So that should be, ooh, Hamza, you got it perfect. So you multiply 5 times 6.9, you should get what, 34.5. And then 34.5 plus 9 gave us a 43.5. Okay, so decimals are fun. We got our calculator. And y'all just punch it right on the calculator like it looks here. 5 parentheses 6.9 for multiplying. Add 9. It'll spit out that answer every time. All right, y'all, one more of these and then I'll show you a word problem where we sort of do function stuff. So this one wants to give me f of x equals x cubed. We're going to find, ooh, y'all, this one got a lot. F of 0, f of -1, f of 5, f of 7, f of -6, and then finally f of a -4a. So 1, 2, 3, 4. So 6 on this one. So here we go. F of 0. I want you to put a 0 in for the x. So you're going to get 0 cubed. And y'all, that's what? A big O 0. F of -1. I did some of these while ago on that cubic graph. But a negative number to an odd exponent will always be negative no matter what. A negative number to an even exponent will always be positive, okay? So -1 times -1 times -1 is a -1. Good job. All right, let's see what y'all do with this one. Y'all find me f of 5. That is going to be 5 cubed. Whoo, y'all are quicker than I can write. Good job, 125. 5 times 5 is 25. 25 times 5 is 125. All right, well, what about this one? F of 7. That's going to be 7 cubed. So, ooh, those are starting to get some big numbers. What do y'all get? 343, perfect. That's why I didn't use a 7 on that cubic graph, because I wasn't going to draw no graph out to 343, okay? All right, what's next? F of -6. That's going to equal -6 cubed. And good job, y'all got my sign, because remember, negative to an odd will be negative. And then it's a 216. All right, y'all are good there. But I got a tricky one left. And that is f of a -4a. That's going to be -4a cubed. So how about the, oh my God, y'all are rolling. Exactly. Negative 4 cubed was negative 64. But y'all look here. On the A, you would treat the A like it's got an exponent of a 1 by it. And when you got an exponent raised to an exponent, you multiply those. And 1 times 3 makes that an A cubed. Hamza, good job. Good job. Negative 64, A cubed. So you got to cube the number and the variable when you're putting that in for that X on that one, okay? All right, that's good, y'all. Y'all, good job on those. So let's look at an application. And let me see if y'all know what this formula is for. Y'all, so they're giving me a formula right here. F of C equals 9/5 C plus 32. Have y'all ever seen this formula? Yeah. So Genesis, yeah. So most of y'all probably have. Y'all might not have seen it with the F of C. Y'all probably would have just seen an F equals 9/5 C plus 32. But y'all, this formula is used to find the Fahrenheit temperature if we know the Celsius temperature. So I can convert it from Celsius into Fahrenheit. And then they got one to convert from Fahrenheit to Celsius. Um, but say you're in England and they got Celsius temperatures, you can plug them Celsius temperatures in and find out what the Fahrenheit would be, okay? Like 100 degrees Celsius is boiling water. Well, that equals 212 in Fahrenheit and stuff like that, okay? So here's the thing they want us to do. Find the Fahrenheit temp um, equivalent to 10 degrees Celsius. So basically, they're giving me a 10 degrees Celsius and they want me to find the Fahrenheit temperature. So that means they're wanting me to put a 10 in for the C. So we're basically finding F of a 10. So we're going to have 9/5 times 10 plus our 32. All right, y'all. So two ways you can do this. One way to spit it straight on the calculator and see what it got. By hand, you can treat the 10 like a fraction if you want to. Remember, you can multiply straight across and do 90 divided by 5, which will give me what, 18? Or you can do what I taught you a while ago, that 10 divided by that 5, making that a 2, and 9 times 2 is still 18 plus your 32. Oh, oh, hell, y'all done got answers going everywhere. Let's see, 50, 50, 50, 50, 50. Y'all got 50s up there. So good job. 18 and 32 is 50. So on this one, MathLab has A, B, C, D. Pick 50 and move on. And technically, that would be what? Degrees Fahrenheit. Okay? Alrighty. So we looked at the correspondence earlier when we said the x's could only have one y value and all that fun stuff. So we got another way that we check if a graph is a function. So how to determine if a graph is a function. Because remember, if it's a function, all the x values can only have one y value. So y'all, what we use? We use what we call the vertical line test. And remember, vertical lines are your up and down, okay? So this vertical line test tells me if it is possible for a vertical line to intersect a graph more than once, the graph is not a function. So vertical line, I'm just going to run my pencil straight across. If it intersects it more than once, it's not a function. So let me do two real quick, and then we'll look at the math lab, okay? So let me do that one. And then I'll do one right here. Oh, so let me see. We did absolute value while ago that looked like that. And then what if I had a graph that did like that? So y'all, let's play with this first graph. Is the first graph a function? So what you would do, you're going to take a vertical line. It only intersected it once there. Vertical line only intersected this graph once. No matter where I go, notice the vertical line is only intersecting my graph one time there, one time there only. No matter where I put it, it only intersects it one time. So that means, yes, this graph is a function. But y'all look over here, vertical line running down, intersects it on top and bottom. This one intersects it on top and bottom. This one intersects it on top and bottom. This one intersects it on top and bottom. So perfect Genesis, that would be a no. So y'all, let me go to Math Lab and see what they're doing on them graphs right there. Oh, that was a temperature one. All right, I'll make this graph bigger for you. Is that graph a function? Good job, y'all. That vertical line ain't going to intersect that graph no more than once anywhere on it. So that's a yes. All right, y'all got one coming up again. Let me make this larger. Sort of like an oval. All right, y'all are quick on that because if you draw vertical lines, it's going to intersect the top and the bottom. So that's a no. All right, y'all are doing good. Let's try the next one. We'll make that bigger. All right, y'all are quick on that one. No, because it's intersected it on top and bottom. All right, y'all, I got a tricky one coming up. Let's see what y'all think. I'll make that a little larger. And y'all, yes, you draw vertical lines all over it. It's not going to intersect it more than once. So good job, y'all. You will just check that and be done. Now, the only thing I got left with y'all. So that's the 2.2. Now, I said today I won't have a support lab after class, but what I want to do is show y'all how to do the problems in the 2.2 support. Okay? So the 2.2 support, they want you to simplify stuff. So y'all, and these are just little bitty small problems. N minus 12n. The n don't have a number in front of it. So automatically the number in front of that n would be a 1. So the question is, what is 1n minus 12n equal? We're all combining like terms is all you're doing on these. So 1n minus 12n gives me negative 11n. Y'all just remember this. We cannot change variables by adding or subtracting. Okay? We can only change the numbers in front. Which means we can only change how many we have. Okay? I had 1n, I lost 12n, so now I'm at negative 11n. So y'all try this one. 5b minus 10b minus 20b. So y'all chat me that answer. Just remember, do not change the variable the way it looks. So you got 5b minus 10b minus 20b. Oh, y'all were close, but y'all was off a little bit. All right, Jayla, that looks more like it. Because you got a positive 5 minus 10 would give you negative 5. And then negative 5 minus 20 would give you negative 25b. Oh, that's all right, y'all. We get y'all fixed on this section. So let me look at this. Let me show you this. A negative and then x minus 11. When you got a negative in front of parentheses, we treat that, guess what? Like a negative 1. Sad face being, that's all right. So, y'all, here's what you do. We want to get rid of parentheses. When you got parentheses following a negative or a minus, you distribute that minus to everything in the parentheses. So what you do is take that negative and treat it like a negative 1. So negative 1 times x. Well, that's a negative times a positive. That's going to make that a negative x. Then you distribute that negative 1 to that negative 11. And negative 1 times negative 11 makes that a positive 11. So Genesis, good job. You had that negative x plus 11. So the negative basically changes the signs. Positive x become negative. Negative 11 become positive. All right, y'all watch this one. A negative and then 77c plus 33d minus 66. Well, y'all, you can't do nothing inside the parentheses because that's a C, that's a D, and that's a number. No like terms. So guess what? Since you got a negative here, to get rid of the parentheses, you got to distribute that negative to all three of those. And remember, that's like a negative 1 still. So negative times a positive makes that a negative 77c. That negative times a positive makes that a negative 33d. And y'all look at that. That negative times a negative makes that a positive 66. So once again, all it did was change all the signs of the numbers inside those parentheses. All right, now let's watch this number 5. It's got a 6a minus parentheses 4a minus 7. So this 6a ain't in the parentheses, so you're going to bring it down. You're going to treat this like a -1, and you're going to distribute it through the parentheses. So negative times 4a is a -4a. Then distribute that negative times that negative, which is what, a +7? Oh, 6a minus 4a plus 7. Can you go further? And if you can, what's your final answer? All right, what we got? Ben, y'all are saying, yeah, y'all are perfect. 2a plus 7. Because all you could do was add the like terms. And 6 minus 4, y'all got me perfect. 2a. And then bring down your plus 7. All right, y'all, let me stop my share real quick. All right, so that's all my lecture. So let me stop my recording.